Hi, I'm Stephen Parkinson. I am a co-founder here at Always Further. And today I want to just touch on our open source project, Nono. Hopefully some of you have heard of us. We are a kernel enforced isolation layer, or a sandbox to many, but a sandbox with many additional capabilities, some of which I will touch on today with some hands-on demonstrations. I will show you our enforcement layer and its composable policies, which you can use to tune to your agent as to what it can and cannot do. Attestation, supply chain provenance, how can you ensure that some of the files that it's ingesting for instructions are what they should be? And I guess particularly for this audience, how can we enable dynamic capability expansion, particularly for agents that are running headless, maybe in the background, in the cloud, maybe as a fleet, and the agent needs a capability elevation. How does it do that? What channels can we use to raise that arm? And can we enable the environment in which it's running, the sandbox, to dynamically expand depending on the request that the agent is after? We've seen the articles in the news. There was only one last week where an entire database got deleted in 9 seconds by a coding agent. Today we believe this gap is structural. Sandboxing assumes you don't trust the workload, but the agent has to act on your behalf. It requires many permissions to enable it to be valuable. It's going to read your code, call your APIs, take those capabilities away, and it's less valuable. It also reads many files. Anything that it reads can be a potential instruction, particularly if we're ingesting skills files, any form of markdown. If that's untrusted and you're not sure of the provenance, there are areas that can be introduced to make the agent do what it shouldn't. And containment doesn't necessarily compose. Containers, VMs, they all assume you're trying to isolate the workload. They don't help when the workload that's running within that is trying to get access to sensitive resources. So before we get onto a demo of Nono's enforcement capabilities, just wanted to touch on the runtime options today. Most of these options are providing workload isolation, VMs, micro VMs, containers. That obviously adds to complexity during development time as well. And they tend to answer the question of, is this workload allowed to run? Not so much, is this operation allowed within this workload and within this run? And this is where we believe Nono's fine-grained capability provides the best of both worlds. So particularly as a developer, you're developing your agent, you're understanding your own agent's behavior. You, as you develop, know which files it should have access to and which resources it should have access to. A particular endpoint within the network, access to a particular database. You can build those policies as you develop your agents so that as you're developing your security as you go. And then as you move your agent into production, you can take that same policy and wrapper your agent with Nono in the runtime. And whether that runtime is in an existing VM because you're running it in the cloud or a containerized environment, you can take Nono with you. So don't think of necessarily Nono as a replacement, though you can certainly do that on the desktop as you're developing. But it's a solution that works with these workload isolation tools in production. So what is Nono? It's agent agnostic. Obviously, if you're using it on the desktop and you're wanting to using it with existing coding agents, Claude, Codex, OpenCode, Copilot, it's a CLI tool that wrappers these. We provide profiles for all of the coding agents and enable you to also create and extend those profiles if you need customizations within your own environment. It's a secure runtime. It's kernel level protection. We're using capabilities and primitives that are built into Linux and Mac OS. We're not reinventing the wheel in that scenario. We are relying on primitives that are built into the operating system. And we're not saying you need to run a particular agent or a coding agent. We are there to be agnostic around that. And we've got developers that are already integrating Nono into their existing CI/CD pipelines, their development environments and scripts. And as I said, it's extremely lightweight to use and an extremely common pattern, and we'll touch on this as we go into the demo. Okay, let's have a look at Nono. Nono is a CLI tool. Here's the commands available to Nono. Pretty much two verbs do most of the work here. Nono run, which puts a process in a cage, and then Nono profile, which manages the policy of that cage. Pretty much everything else is observability around that, in addition to the session management, which we'll talk about a bit later. So a lot of people will run or want a sandbox to keep their coding agent under control. So here's one for Claude. And there are profiles that are made available to Nono. We've just created a registry, which is an online capability to enable you to pull down community contributed profiles and also profiles that are created by us as maintainers. So here's one for Claude. It's asking me, do I want to allow read-write access to the current working directory? So you typically, switch into the working directory where you want to give your coding agent access to, and all subdirectories, and run the coding agent. You can pass in a command line parameter, allow current working directory if you want to skip the prompt, but that's kind of there as a safety net. You can see once you run the capabilities that are made available to the process, Claude in this case. And Claude is quite messy. It requires access to quite a few files and subdirectories, and it iterates all the time. So that's one of the reasons for the online registry, so we can keep the profiles up to date as the coding agents like Claude iterate through releases. So, okay, we've run our coding agent, but you can also just use Nono to sandbox discrete commands. In this example, we are going to block the network and just try and do a curl. And you can see that the sandbox is applied. Okay, it's doing what you would expect it to do. But let's do something a little more interesting, which is we have users in the community that are starting to use Nono within their CI/CD pipelines. Maybe you have a repo that you want, or is untrusted, that you want to perform a make against. Well, let's do it in a sandbox. So here I go. I've got a simple one here. I've cloned it down. You can just see it's very simple. It's npm based. So I'm going to run it with a Nono profile for Node. That enables me to run make against it. I'm blocking the network, and you can see that that executes very quickly. Again, Nono is a really lightweight wrapper around this, so you can just start integrating it into your pipelines. And you can see that I've run that within a working directory. I've blocked the network, so its blast radius is pretty contained. Okay, so let's start looking at some of the profile capabilities of Nono. So profiles are essentially policy bundles with built-ins within Nono, and you can also write your own. Profiles are made up of groups, and each profile is sort of composed from name groups, which are smaller bundles where you can mix and match. So you can write a rule once and compose it everywhere. Let's have a look at one of these, which is the deny credential, and everything that counts as a credential, SSH keys, AWS configs. Any profile that pulls in this group inherits the whole list, and you can see how that's mapped to my current working directory. Let's have a look at the profile for Claude. You can see that's quite extensive in terms of the security groups. But it also means that when you're looking at the profile and what might be wrappering your agent, it's fully auditable. There's no hidden rules. You can see what is being wrappered or what's forming the wrapper around your process. And there are tools built in that, there's a default profile, Claude profile. You can look at the differences between them, what might have changed. So again, as you're iterating and creating your own profiles, it's very quick for you to compare across baselines. As I talked earlier, we have this online capability to provide packages of these policies. So here's one. I'm looking for the one for Claude. I can pull this down. I've already got it installed, so I'll do it with the force parameter. And you can see the elements that are making up this profile. There's also some plugins there that enable Claude to be aware of Nono itself, which means that when you're having your interaction within the Claude session, if it gets denied, it can use Nono, look at the profile schema, look at the profile guide, and help you to potentially widen the profile should you wish. We talked about supply chain provenance earlier in the deck, and I'll talk about this next in a later part of the demo, but we've built supply chain provenance into our own profiles, so you can trust the profiles from where they're being pulled, and you can check back to the origin. It doesn't mean to say that we're hosting the profiles, but we're hosting the signing, and you can host these profiles in your own GitHub repos should you wish. So this is great. Now I can really let Claude off the leash. I can run Nono and Claude with dangerously skipped permissions because I know Nono is going to do the sandboxing for me. So there we go. I can run Claude and just let it off the leash. Okay, that in itself is great. I can do that individually, but we are talking about wanting to run potentially multiple agents, and we're on a conference here about background agents. How about doing this within our own terminal? So one of the advantages of Nono is, of course, that it's extremely lightweight, and we have session management built into Nono, a bit like a Docker. You can do a Nono PS. These are the sessions that are currently running on my machine. You can see that I'm attached in another window, and a bulk of these which I am detached to. And we use Nono obviously within our own development. So we obviously do dog fooding on Nono, and you can see that I can attach to or I can create a session and then detach from it so it runs in the background. So here's one. It's exactly the same, but this time you can see there's a detached associated with this. So the session gets created. You've got an ID there. I can now look at this from a Nono PS perspective. You can see I've got a new one there at the top. Let's attach to it. There is my Claude session. I'll get it to do something straightforward. Okay, I'm going to disconnect from that, and there's a short key that you can enable yourself. Then we can do an inspect of that session, and now I can attach back to it, and you can see that the poem has been written in the background. So this is great. All of a sudden I can run multiple Claude sessions and get a view over the top of this. So we've written our own wrapper around Nono. We call it Nono Dev, and we use this to help us with managing our own repos. Basically wrappers a Claude session and enables us to set it going with dangerously skip permissions, to do a triage against a particular GitHub issue, build a new feature, to switch to a new working directory and run it in a bare fashion. And then you can manage those sandboxes pretty much as we were doing there with the session management. We've got work trees built in and knowledge graphs to help us explain our so we don't reuse a load of sessions tokens in the sessions when looking at the repos. And then here's I can list my background sandboxes that are running. This is pretty much an overlay on top of the Nono PS. I can see the amount of changes in a particular work tree. And again, similarly to Nono PS, I can inspect what was the command and the working directory for those particular sessions. So 3 takeaways I would say from this. 1, the cage is kernel enforced, applications can't bypass it even if they try. 2, policy composes, groups into profiles, profiles into signed packs, which is the registry, and this naturally slots into your AI tooling that most needs it. So 3 things to show you in this session. Attestation, signing the files an agent reads, so an injected one can't replace them. We'll do that on a common skills file. Audit, every sandbox action hashed into a tamper evident log, and rollback, an atomic undo of any session. So we've just got a simple directory here with a couple of files in. One is a skills file. Obviously the coding agent reads on launch and tells the agent how to behave. And I've got a simple working doc here, just a report markdown file. Let's have a look at the skills file. It's just a simple deployment skill for kubectl. So what we're going to do now is initialize a trust policy that gates the skills file and any other skills file that gets created or put into this directory. This policy now becomes a tracked artifact within the repo. We are going now to sign the policy. The policy itself is tamper evident. If anyone modifies with it, then the signature breaks. Now we sign the legitimate skill. This is the one that we trust. So that gets signed. And now we can look at our trust list. So we have 2 signatures, the policy itself and the skill. And anything else that matches the include pattern but isn't signed will be refused. So you can see that on macOS, which is where I am at, files created mid-session, they don't get verified. It only gets checked at startup, but this is a capability that's built into Linux. So you can see there I have done just a quick cat of that skills file within a Nono sandbox just to check that what's in the sandbox is verified and it's readable. And you can see that just cats out the skill. So now let's just quickly create an untrusted skill. We've now created this within the working directory. So just imagine someone's dropped this into a project. It's a backdoor. Worst case, it instructs the agent to maybe curl from a malicious URL. You can see it there on the disk, untrusted skill.md, and you can see the trusted policies there that are now within the repo. So let's see if we can look at this untrusted skill. And you can see that in this scenario now, our skills file passed because it was the publisher was verified, but the untrusted skill wasn't. And so the verification failed, and so it wasn't made available to the process within the sandbox. So if you're doing this with Claude, for example, Claude would not be able to see and use that file. So let's just remove that. So now let's move on to audit. So we're going to now run a sandbox command with 2 flags on it. Audit integrity records every event into a Merkle log and rollback snapshots before and after. The wrap command modifies report markdown and we create a new file. Both will be captured. You can see again we get the warning around the includes for files that match the policy. So now let's have a look at the 2 most recent files that were touched, the 2 most recent commands, and you can see that those are the 2 that I passed in as part of the the command through Nono run, we modified the file and we touched another file. Let's just have a look at the trail for that particular audit session. And you can see the session expanded, every syscall the sandbox process made, open write exec, and you can see the read of the skills file. The reply to the report markdown and the touch of the new file. And let's just verify that audit. And verify recomputes every event hash from the recorded data, checks the Merkle root, and if anything in the log was tampered with it after the fact, then it would fail. Now, this is all happening in a supervisor process wrapped outside the sandbox, so the agent can't even attempt to tamper the audit trail, but if something else was to get access to it as well, the mere fact that it's a Merkle tree makes that extremely, extremely difficult to tamper. So let's just look at the rollback capabilities built into Nono. We'll have a quick look at the snapshots. The same run, we took 2 snapshots, one before and one after. Let's have a look at the difference between them, and you can see that we have this modified by the agent put into the report file. And there you go, you can see if we do a cat of that, you can see it's been modified by the agent. So now let's roll this back. Well, what would happen if we can do a dry run on it? We can preview the restore first and see exactly what will revert. Now we'll actually do it. And now we can see that the report file has reverted back to its original text as though the agent never ran. So 3 guarantees, all kernel enforced, signed code, only the artifacts you've explicitly trusted get loaded, tamper evident logs, every sandboxed action provably recorded, and you have an atomic undo, any session that can be reversed in one shot. And the OS enforces the cage, Nono records and reverses what happens inside it. Okay, so for the last demonstration, just wanted to touch on capability expansion, how we might do this dynamically. So you have your sandbox set up, it's been framed with its capabilities and a profile, and then in life, an agent requests access to a resource, a file in this case, and how we'll use a channel, Slack, to surface that request, get an approval, and to in life expand the capability of the sandbox so the agent can continue running. So this is, you can think of this might be running headless. Slack is your approval mechanism, and this is different obviously to background agents that have finished their coding and you're looking to steer them to the next job. This is around the security wrapper that is enforcing the capabilities of the agent, requesting an additional permission and using the workflow to dynamically grant. So you can see the current working directory. I'm in this directory called Elevation Demo. I have another file here, which is the one I am going to grant to the agent. Now we know that Nono works on the basis of profiles. So I have checked that using a Nono Y command, if I pass in this profile and I'm asking it, can within that profile, can it read this file? And you can see that the profile by itself denies this capability. So we know it doesn't have access to this file when it runs. So I'm going to run Claude now, passing in that profile. You can see there's a new flag now called capability elevation. This enables the wiring back to Slack and also the dynamic capability of the sandbox. I'm running it with dangerously skipped permissions on the current working directory. The capabilities get granted and Claude is now running. And what I am going to ask Claude to do is show the contents of this file, which you know it doesn't have access to. And Claude's going to have a noodle on that, and you can see now that we have a grant come through to Slack. It's asking for read access to this particular file, and it's using this secure Linux mechanism called sepcont notify. So the sandbox is wrapped by a process called the Nono supervisor, and it's the supervisor that's intercepting this particular request. And if I allow this read, the supervisor is then again going to provide a secure injection and access to the sandbox to enable Claude to now read that file. It's also asking for a read to the directory. We don't need to give it read to the directory. And you can see now how you have an in-life grant and Claude is able to access the contents of that file. So this is it's obviously a simulated workflow that we've got set up here, but you can see how potentially if you are running many agents within kernel sandboxes that might be running headless, you've defined your profiles, but all of a sudden they get stalled because they require access to an additional resource. You can use a mechanism such as Slack to surface those and surface their intent. Now you might want to automate some of the approvals depending on the resources that are accessed, but again you may also want to introduce human in the loop. So this is an area we're actively working on. We're looking for enterprise prospects, people who might be using Nono or be interested in using Nono in the enterprise. So if you are, please do get in touch, and we'd love to work with you. So hopefully you found some of the information I shared today useful. Anyone out there interested in helping shape Nono, particularly in some of these enterprise areas, how you might take the open source project, start to use it at more scale, provisioning of policy, resource bounds, supervision, touched on that with approval levels through Slack. Infrastructure, are you interested in instances of Nono to run your own agents? And provenance, you saw the attestation, and maybe interested in also our audit and rollback capabilities at scale and feeding those into your own systems. We're promising dedicated co-development during a period, collaboration. If this is an area that you are interested in, please do reach out and get in touch. And for those of you that just want to look at Nono from a community perspective, please go to nono.sh. You'll find our GitHub and Discord communities from there. Thank you very much.